Always feel that hard. I like it.
There it is. Don't mind the background noise. It's just some normal school stuff. Just like the title. Aha.
All right, place the dry erase markers down until I ask you to use them. Has everyone logged in? Now, you should have a note-taking guide that you have also that you picked up for significant digits. We're going to go through significant digits. They're going to be an important part of this class. And so there are going to be times, please keep the dry erase markers capped and down. Please don't let me see them in your hands. I pay for those things, and they are not cheap.
Dollar store.
They are not cheap.
You can go to
You get two at the dollar store. Two. You know how many kids I have? I have 180. That's not cheap.
Two per table.
That's busy, bro.
Two per table, and just use the same ones.
We use them throughout the year. Those dry up in a few weeks.
Yeah, okay. That's like
There you go.
Add
Money
vinegar.
is my money. It's not the school's money.
Add vinegar.
My money.
Well, then add
All right,
to the bring your own.
Significant. Quiet. Scientific figures and measurements. Sorry, it's a lot. Yes, significant digits. You won't drop out. You'll come back. Yes, and it should say significant digits. Yes, it should say significant. Significant digits are significant figures. Yeah. There you go. You will. I'll tell you what you actually need. It just says examples. Most of the actual information is already down. All right, most of the information. Quiet. Most of the information that you need is already written down. The only thing that I will have you to write down is examples that you will need to add. So, first rule of significant digits. First, non-zero digits and zeros between non-zero digits are always significant. So a non-zero... All right, now significant digits. Non-zero digits and zeros between non-zero digits are significant. First, make sure that you understand what a non-zero digit is. What is a non-zero digit?
A zero that's not zero. I mean,
I was going to say a zero that's not zero. A digit that is not a zero. So that means 1 through 9 is always going to be significant. Write that in your notes where it says examples. 1 through 9 is always going to be significant. So any digit that is 1 through 9 will be significant. 10 has a 0.
Wow.
Okay, guys, come on. If I say 1 through 9, anything that has a 1, 2, 3, all the way into 9 is going to be significant. So if it's 29, a 2 and a 9, they're significant. So anything that has a real digit, 1 through 9, is significant.
10 and the rest.
Now, anything that has, it also says that, non-zero digits and zeros between non-zero digits are significant. So if there's a 0 between a non-zero digit, then it will also be significant. So that means 101. Write that on your paper. 101 has a 0 in between, so that means it is that 0 that's in between will be significant. 101. Write that down.
101. I'll be careful with bumping into the table. It's very sensitive. The microphone hears the hearing me whispering. It's very sensitive.
All right, so 101. Since there is a 0 in between two non-zero digits, that means that that 0 is significant. So if I ask you how many significant digits, there are 3. So the 0 is significant because it's between. That's what the rule says. So, rule number 2 says that leading zeros are not significant. So leading zeros, and write these, make sure you're writing these examples down. Yes.
What you got 2 numbers?
Are they in between?
But it's 2 of them, not
Or are
1.
they in between?
It's 2 of them, not 1.
All of those are significant.
There you go. That's all you have to say.
I asked you were they in between.
But actually, what?
Okay. Leading zeros. Let's look at those now. For example, if I write 1,000. If I have 1,000, these zeros are considered to be leading. So that means that they are not significant.
So you don't have them back.
There you go.
No.
So that means there's only one significant digit here. Leading zeros can also look like this. If I have 0.001, these zeros are leading. They're just placeholders. So they are not significant. There's only one significant digit here. So just to review that, rule number 1 says all non-zero digits are significant. Zeros in between non-zero digits are significant. Leading zeros are not significant. So, now let's look at this. If I have this number, how many significant digits do you see there?
3.
There's 3. Which ones are significant?
2.
This one, and this one. Why isn't this one significant?
Because it's leading.
Because this is a leading zero. Now, if I have $2,000, how many significant digits? 1. Why aren't these significant? They're leading. They're just placeholders. So, if I have,
What?
if I have this, how many significant digits? 4. Why? Because they're not zero. Correct. All right, so moving on. Now let's look at some practice on here. On your dry erase boards, this is what I want you to use those for. I want you to write the number of significant, put number 1, 2, 3, 4, and tell me how many significant digits each one of them have. 1, 2, 3, 4. Just write number 1, 2, 3, 4, and then tell me how many significant digits does each one of them have. If your marker isn't working, just let me know and I'll give you a new one. I know some of these have been around the way. So for question number 1, how many significant digits were there? 6. For 2, how many significant digits? 2. Question number 3, how many significant digits? 3. And 4, how many significant? Should be 7. So, are we clear with how to identify for rule number 1 and 2? Now there are 2 more rules. Never just 2. All right, so next. Identify the number of significant digits on this one. So write out 1, 2, 3, and 4 again and tell me how many. We're still looking at rules number 1 and 2.
What's your favorite animal?
Bulldog.
All right, so for question number 1, how many significant digits? 1. 1. For question number 2, how many significant digits? Question number 3?
2.
Question number
3.
3. Hey, stop playing. I can take time to a certain thing. All right, so now moving on to the next one. Rules number 3 and 4. You have those on your note-taking guide. Rule number 3 says that zeros to the right of all non-zero digits are only significant if a decimal point is shown. So if you see a 0 to the right and there is a decimal point, then the zeros are significant. So the way that looks, for your example, if I have 1,000, and then there's a decimal point there, those zeros are now significant. So I have 4 significant digits. Now, if it was just 1,000, then it'll be 1 significant digit. This decimal point makes those zeros significant. That also looks this way. If I have 0.020, since this 0 is to the right of a 2, that means it is significant, and there's a decimal point here. So that means I have 2 significant digits. That's what that rule states. So make sure that you write those examples down, that you have those in there, because you will see significant digits such as this. So once again, if there's a decimal point there, rule of thumb is that it's going to be significant. As long as a decimal point is present, any 0 to the right of a non-zero digit will be significant, as long as it's to the right and there's a decimal point. So all of these are significant. Now, rule number 4 says, for values written in scientific notation, the digits in the coefficients are significant. And we're going to talk about scientific notation. So basically what that means, so if I have scientific notation, which is, let's say, so if I have, for example, 4.60 times 10 to the 26th, this is scientific notation. Any number that's written out here, this is your coefficient. All of those are significant. You do not pay attention to that number, the exponent. So if I see something that's already written in scientific notation, then that means I have 3 significant digits. Because these are just extra zeros. Just like if you look at this number that's on the top of my board, that's 602 sextillion, which is a very huge number. But the 602 is the only significant digits. The rest of them are just zeros, placeholders. So another example will be if I have 6.00 times 10 to the negative 4. All of those numbers that are in the coefficient are significant. So I still have 3 significant digits. Because once again, those zeros are to the right of a non-zero digit. And there's a decimal present. Now, as we work with these, hopefully the rules will stick, but you just have to practice just to truly understand. But those are the only 4 rules you have to remember for for significant figures. So, on your dry erase boards, identify how many significant digits each one of them have. All right, hold the dry erase boards up. Let's see what we have here. Good, good. That first and last, check that. Good, good. Number 2. Yeah. You got 1 you need to check. You got 1 you need to check. You got 4. That number 4, check that one. You got 1 you need to check. 2 you need to check. 2 you need to check. 1 you need to check. Good. 1 you need to check. 1 you need to check. Actually, I'm sorry, 2 you need to check. Nope. That last one. And no, 2 you need to check. Good. Good. Turn around. Good. That last one. 2 you need to check. 2 you need to check.
I got it.
We're going to talk about. All right, so the first significant digits do you have? 4. The second one, how many significant digits? 5. How is it 5? What's the coefficient? It's 5. It's 3.0500. That's the coefficient. We just said in the rule. The coefficient for anything that's written in scientific notation is all significant. So all of those numbers are significant. We don't do the rules because that's rule number 4. That's what it says. For number 3, how many significant digits? 4. And the last one, how many significant digits? 4. Because the other zeros are what? They are leading. You say what? No, because they're leading zeros. So you don't count anything in the front. They have to be to the right of the decimal point. All right, so learning check. Answer these. You can write 1, 2, or 3 for the answers. So the first one says, which answer contains 3 significant digits? You can have multiple answers. So which one contains 3 significant digits? Write that on your board, then hold it up. Just for number 1. Just for A. 3 significant digits. Hold the boards up. Keep them up. Keep them up. In the front. In the front. I want nobody to change their answers. I think see yours. Okay. So should be 2 and 3. I said it'll have multiple answers. 2 and 3 have 3 significant digits. So let's look at B. B says all the zeros are significant in which one? All the zeros are significant in which one? Hold up your boards. Correct answer should be 2 and 3 again. Remember, 3 is a scientific notation, so it's all significant. And in 2, they're significant. Question? If it's in the coefficient, it's significant. So whatever's written out, if I have 5,000 times 10 to whatever, this is all significant. No matter what's right there, it's significant. C. It says 534,675 rounded to 3 significant digits. So when you round that to 3 significant digits, okay, and we're going to work on the rounding part of this, but the correct answer would be, once again, 2 and 3. 1 is just 500 and something. It still has to be 5,000 something. You can't just drop it and change the amount. Oh, I have 1,000,000, and I'm just going to make it 500 now.
Such a skipper. Get it. Once again.
All right, so what I would like for you to do before we move on, place the other paper in front of you. The one that has the actual significant digits on it, capital markers for now. Now we're going to look at part C, since that's what we talked about first. Looking at part C, you're going to go through 1 through 18. Identify the number of significant digits and just write that number over to the side. So, do that now. Part C only. Just write the number of significant digits. You have the rules in your notes. You can go back and look at your examples in your rules. Please don't drop those calculators. You drop it, you buy it. $200 a piece. Not those. Not these. Part C. Make sure you're doing part C at the bottom. If you still have questions over this, let me know, and I can come briefly try to redirect you a little bit. Because you have to use your rules. This is rule of thumb to help you remember. Easy way. Each time, any zero in the middle is 3. Come on, 5. It doesn't matter as long as the non-zero digit is in front of it.
For my birthday, Sunday.
Only time, this is the best way to look at it. The only time
I'm not playing with rubber because
Only the practice with it. It doesn't come easy off first. No, that's not the now, if that was a 1,
You do follow.
so as long as, even if, as long as in between, I'm following this to anything that's in between. Also, if you see a decimal point there, here, see a decimal?
As you looking at me.
Zero, right? Any non-zero
That's not just idea. Except for love. Funny.
As long as now we
You will get cool.
It doesn't.
I don't know what to do with this. I've never done this before.
1,000 zeros, as long as they're in between, they're
Done your lifetime, cutting his keyboard navigate 1 through 6.
yes, as long as they're in between anything.
Okay, but it's noise. Okay, screw it. Now it's working. Again, it works.
Yeah, she wants to play.
I haven't been to my drive in a while.
Do you have a decimal point? Oh my God! All right, guys, let me have your attention real quick, quiet, because most of you I know have finished. To help you to better, I see some of you are struggling still with the zeros and identifying them. There are only 2 situations where the zeros will not be significant. So I'm going to write these down, add these to your notes. Quiet, quiet, quiet. Put them, add it to your notes. Now I'm going to So, the only time the zeros will not be significant, if they are like this and there's no decimal point, then they are not significant. So anything that's written in that sort that has no decimal point and just zeros following behind are never significant. Also, when they are written like this, they are not significant. That is the only time. Every other time they're going to be significant. If I have a number such as they're in between, it doesn't matter if it's 100.001. As long as they're in between, they're always significant. If I had this, and there's a decimal point there, they're all significant. So these are the only 2 times that they will not be significant. Anything else is going to be significant. So as long as you can remember, if they look like either of those two, they will not. Anything else, as long as it's there, more than likely it's going to be significant. Unless they are leading. So, please make sure you have that in your notes. Hopefully, we're a little clearer. So, for question number 1 on that paper, how many significant digits do you have?
I got a question. Yeah.
We're going to go through all of them. So, we'll hit that one. Question number 1, how many significant digits? 6. Question number 2, how many significant digits? 2. Question number 3, how many significant digits?
5. That's 5.
5.
7.
Yeah. You said
Hold up. Does question number 3 look like the one I have X's on?
No.
Is there a decimal point?
Yes.
Are those zeros to the right of a non-zero digit?
Okay.
Are they to the right of a non-zero digit? They are significant.
I thought you said if it's a decimal point here, you gotta lead.
Oh, you better show something.
There is, I told you, if it doesn't look like this, these are the only 2 ways they're not significant. If they're the 7.00, these are to the right of a non-zero digit. They are significant. They are to the right of a non-zero digit, so they are significant. That's the rule. Stop trying to defend yourself against the rule. Question number 4, how many significant digits? 5. Question number 5, how many significant digits? 2. Question number 6? 3. Question number 7?
4.
Number 8?
6.
Number 9? 10?
3.
Number 10, how many?
3.
3. Is that 0 to the right? It's significant.
It don't make no sense. Because one rule says something, and the other rule says something else.
You have 4 of them.
Why?
You have to apply all 4. That's not life. Life has many rules. And when you learn in this class, there are going to be many of rules you have to know. And you have to take this and apply it to the other 15 other rules you got to learn. Question number 11. Number 12. 8. Is that 0 to the right? Is there a decimal point? It's significant. Question number 13. 5. Question number 14.
3.
Question number 15. Question number 16. Question number 17. And number 18. 6. Now, once again, for those of you who are still struggling, even though I told you, those are the only 2 ways they're not significant. If they are not just following behind with no decimal point, then they're going to be significant. So there are only 2 ways that the zeros are not significant. So please write those down in your notes. Many of you, as I came around to assist you, one thing that I need you to get out of the habit of doing, you place your notes away from you while you're doing the work. And then you have questions and you second guess yourself. The purpose of you having notes is so that you can use them. All right, next thing. For the addition part on your
Your
notes,
screen.
cross through that. We're not going to do addition and subtraction. The one that says addition and subtraction, you won't ever use that. So go to multiplication and division. Now, multiplication and division is a little different. It says you round or add zeros to the calculated answer until you have the same number of significant figures as the measurements with the fewest significant digits. So basically what that means, when you are multiplying, anytime you multiply any number, you look at the digit that has, you look at the set that has the fewest number of significant digits. For example, if I have 27.3 times 2.3, and I'm solving this, which one, how many, first of all, how many significant digits do I see here? 3. How many do I see here? 2. So since this one has the least number of significant digits, my answer should have only 2 significant digits. So multiply this out. Do that. Put it in the calculator. You have to press OK when it first comes on. 62.79. All right, so that's the answer that you got on the calculator. But we need to make this only 2 significant digits. So how can I change this to where it equals only 2 significant digits?
Add the 2 and the 6, add the 7 and the 9.
63. Make it 63.
What? What type of math are you doing? What would you do? Yes, you will round, so what would you get?
63.
63. That will be your answer. Because it only needs to have 2 significant digits. So your answer, you would just round it up to 2 significant digits. Now, for those of you, first of all, this has just been introduced to you. So don't stress because you don't get it off the bat. You will learn it over time. Some people get it off the bat. Some people need to work until you get it. There's a lot of things that you're going to cover in this class that is not going to be easy for everyone to grasp. That's why you work on it. Looking at another example, and make sure you write these down in the area that says example when I do a couple of these. You can write the next one. So let's look at 0.07 divided by 0.020. So first thing, how many significant digits do we see here? 1. How many do we see here? 2. Because remember, those 2 are significant. So your answer needs to be in how many significant digits? 1, because you also go.
4.
So what's your answer? Just give me the full answer.
4.
Give me the full answer in your calculator. 3.5.
What did you calculate? Oh.
So you have 3.5. So then if you round this up, it's going to be what?
4.
Oh, 4.
So that will be your answer.
Where'd the ball go?
Oh, wow.
I was looking at the 5 and I was running the 5 up.
So you got this written down as an example.
Wait.
So once again, with multiplication, you multiply, you divide just like you normally do. The only difference is you have to look and see how many significant digits. So you look at the lowest number. Your answer needs to be expressed in numbers. So on test, you will see, on your first unit test, which is a week from now, you will see it will ask you to round something to 3 significant digits. So when you get your answer, it needs to only be in 3 significant digits. So if you just write what's in the calculator, it's going to be correct. Practice on this, so don't stress just because you don't get it today. Hopefully you get it the next day. Let's add another example. Let's look at 202. 202 times 45. So we have how many significant digits here? And how many here? So when we multiply, we get what? 90. I know what you said. You said 90. What? All right. So now, what will be the answer? How many significant digits should it be in? 2 is the lowest, so it needs to be in 2. So your answer is going to be what?
91.
It's going to be what?
91.
90.9.
You say what? We rounded. You say what? How many significant digits are up there?
4. 2, 3. 4. 3. To the right. 3. Which one you talking about? The left or the right? 3. On the left.
Are these zeros significant?
No.
There's only 2 significant digits. You cannot just write 91 because 91 this is 9,000. So if you just put 91 there, that's not the correct number. So you still have to hold the correct place value. You can't just disrupt the place value. So you just round it up, but you still have to put those placeholders there. They're not significant, but they have to be written. Now, make sure that you write this down as an example also.
Not you.
So once again, you cannot disrupt place value. So let's look at one more example. Yeah. So we have how many significant digits here?
3.
3. 1. So we go with the lowest amount, which is this one. Now, when you multiply, what does your answer come out to be? 0.000
845.
It's 3 zeros.
It's 0.00084.
846.
There you go. I pulled up the calculator.
Yeah, that's correct. It is
I need the viewers to see it.
You will eventually when I start getting stuff out. All right, so how many significant digits do you need? So how we round this off to? 0.00 what?
9.
9. Because we take the 4. 4 is less than 5. So
Too much math.
oh, I'm sorry. Yeah. My mistake.
Yeah.
That's my mistake. I guess so. Now, the way that you're going to actually oh my God. Because I don't want to jump right now into scientific notation because I'm still struggling with significant digits. Many of us. It's an easy process. Now, I guess I'll mention scientific notation and we'll finish this up next class. So, scientific notation is something that you will need to understand how to write because as you see, we deal with very huge numbers because most of the stuff that we see is very small in chemistry. So our numbers are super big. That's, like I told you, 602 septillion. So you have to express that in scientific notation in order to write it correctly and solve for it, because numbers that you're going to be doing math with are very large. So you have the quiet, so we can move through this. You have a definition for scientific notation and for standard form. So I'm not going to. You can read. So for scientific notation, the whole basis of scientific notation is if I give you 1,000 and I ask you to express it into scientific notation, remember that there is a decimal point here, even though you don't see it. Where is the decimal point?
Behind the 0.
Behind the last 0. It's just invisible. So take our decimal place until we get to the last non-zero digit. So we stop behind the 1. So we move it to which direction? Left.
Oh, wait, never mind.
So when we express this in scientific notation, we have 1. We place a power of 10. And we move the decimal place 3 times. So that's how you express 1,000 in scientific notation. And it's in the rules. It's right there on your paper that tells you to move the decimal place over. Now, write these down. Make sure you're writing these down where it says scientific notation for examples. Let's look at another one. And these are whole numbers. We're going to do decimals next class period. There's whole numbers in there. What? Now, 2000. 2002. So let's look at this number. Now, to express this number, we need to do what? Where is our decimal? In the back. So we're going to move it how many directions? 1, 2, 3, 4. You always go to the last non-zero digit. There should only be one digit always in front. So, how would you write this? 0.002. Because why do you write all of those?
Okay, that's the whole number. That's the number.
All those numbers are significant. So, 2.002, you say what? Times 10 to the fourth. Because you moved it 4 times, yes. So we'll work on some more of these. Make sure you hold on to the notes. Go ahead and log off the Chromebooks and just close them. I'll put them up, just close them, put them on the edge of your table. My next class is coming in anyway. Calculators, place those calculators back in the front and the correct number. The numbers are written on the side. Please place them in the correct number.